So learning unit 4 is really about protein function. So we're going to just look at one brief example of protein function. We'll spend the rest of the course talking about how different proteins work, but we're specifically going to look at two proteins in the globin family, and those are oxygen binding proteins. So we're going to look at myoglobin and we're going to look at hemoglobin. Again, myoglobin is the protein that kind of sits stationary in your muscles, and then hemoglobin is the oxygen binding protein that circulates in your blood. So we're going to kind of learn how both of these proteins work and how this works in concert with carbonic anhydrase, which we learned about as one of the players in CO2 cycling in your body. And so we're going to learn about how all of this works together to help maintain blood pH, how to deliver oxygen to your respiring tissues, and at the very end of probably this 2 to 3 day learning unit, we'll actually put this all together in a skit that will act out to understand how all of these players work. So we begin kind of thinking about myoglobin structure, thinking about what heme is, how that binds iron, the difference between oxidation and oxygenation, so understanding the differences between the loss of electrons, which is oxidation, not something we're interested in, and then oxygenation, which is the reversible binding of oxygen. We'll talk about how carbon monoxide poisoning works and how that relates to the ability of iron in the heme to reversibly bind that sixth ligand. And we want it to be oxygen, but again, if there's carbon monoxide around, that can be problematic. After we kind of look at how binding events happen in the context of myoglobin, so again, we'll look at a typical binding curve and understand how binding curves work. Then we'll move on to hemoglobin. Hemoglobin is a little bit more complicated because it's 4 protein units kind of together in a tetrameric protein. So we'll have to think about quaternary structure, and importantly with this protein, quaternary structure actually has a lot to play with function, because what happens is as you bind oxygen, the conformation or the shape of this protein changes, and that changes its affinity for oxygen. So we're going to kind of put all of those pieces together as we understand how hemoglobin works. At the very end, we'll kind of have a little bit of a discussion as to how blood pH can kind of affect your oxygen binding ability, and how exercise, which can lower your blood pH, can actually allow you to deliver more oxygen to your tissues. We'll talk about what happens at high altitude and how that affects your oxygen binding, and why some athletes may choose to train at high altitude to have better oxygen carrying capacity at lower altitudes. We'll spend a little bit of time at the very end kind of going through some different examples. We'll talk about sickle cell anemia, and so we'll talk about how the hemoglobin is different there. We'll talk about its correlation and connection with malarial incidence, and we'll talk about fetal hemoglobin a little bit more. We mentioned it briefly when we talk about carbon monoxide poisoning, in that fetal hemoglobin actually binds oxygen more tightly than maternal hemoglobin, and why that's important to allow for a growing fetus, but why that ultimately ends up in fetal fatalities with carbon monoxide poisoning. So very, very brief learning unit here as we introduce some concepts of protein function with one example in terms of oxygen binding proteins.